something along there. We are. Excellent, and we're back. Oh, goodness. Okay. First of all, just a small tidbit of information. I was not here on Wednesday. Obviously, you already know that. You already know why. It was incredibly efficient. It was so crazy. I had to walk for like literally 15 minutes, and I had to check in at various checkpoints showing my ID, and then eventually they injected me. And now I feel like, I could lift a car. No, not at all, even remotely close to it. I am exhausted. My arm still kind of hurts a little bit, but them's the breaks. I got to go back on March 17th to get the second dose, but that won't affect you guys because March 17th is supposedly supposed to be an A day, so that won't affect you the second day that I have to miss as a result of that. The one thing I did miss. Oh, the one thing I did miss. Do you know what Wednesday was? Wednesday was Derek's birthday. Anyway, sorry, just the reaction was great. Derek actually just got his power back like less than a week ago, living in Texas. Very scary time. He was without power for like 3 or 4 days. He posted a picture of it was like some kind of like ceramic pot. I mean, it wasn't ceramic. It was made of some material where he could like put a bunch of wood in and like light it on fire. It was crazy. He created like a little oven outside on his patio. Oh, there was like 3 or 4 inches of snow. But crazy times. Oh, Derek, come back to me. Anyway, as for today, what I would like to do is, number one, I would like to go over at least 2 of the problems that I assigned you on Wednesday. I have not had the opportunity to go through all of them just yet. For those of you that turned it in, the page out of the book. I'm still catching up from everything from like Tuesday and Wednesday. I'm a little bit behind on those things, especially the assessment that you guys turned in as well. But I'm hoping to, catch things up today. We'll see. I've been going to bed at like 8:30, 9 o'clock. I've been so exhausted. This vaccine really kicked my butt. But we'll see what happens. Then, after we go over those couple of problems, I do want to dive back into hypothesis testing. I have some additional information to kind of build upon what we've been doing with setting up these hypothesis tests. Yes, and I get to talk about skydiving today. You don't know what that means yet, but you will. Skydiving. Oh, and I get to tell you my famous phrase that I hyped on Monday, didn't I? Did I hype a phrase on Monday and I said I'm going to leave you in suspense? No? Some people are nodding yes, some people are nodding no. That's okay. I'm excited. Anyway, so first thing I would like to do, like I said, I want to go over a couple of those problems that you did for me the other day. For those of you in the live chat, I can still see you right here. But for those of you in the live chat, if you would be so kind as to leave a comment, that would be absolutely wonderful for my records. And we can kind of go from there. Let me zoom in on this sucker. There we go. Can I make this full screen? I really do. Hold on. Fit to width, single page, bookmark. Can I just do this? That's not bad. All right, that's okay, I guess. Cool. I'm looking at number 12, basically. 12 out of the textbook. Obviously, for those of you that are here, you might be able to see a little bit better than those that are in the live chat. But obviously, if you do have the online textbook open, you could easily access number 12. But number 12 was just basically, okay, here's the hypothesis test. What are the mistakes that they made? What are the mistakes that they made? And I went through it and I made just a mental note of all of the mistakes that they made. But then I went to the back of the book just to double check. And I was pretty spot on. I think I was a bit more critical. I was a bit more critical than the textbook was. Because personally, I would have changed at least 8 or 9 different things. But the textbook said 7 things that were potentially wrong with this hypothesis test. And man, there's a lot of information here. Let me actually go back for the context of the problem, because I got to go back to the previous page for the context. That's ridiculous. Number 12. It says in 2016, the Centers for Disease Control and Prevention reported that 36.5% of adults in the United States are obese. Okay, let me write down some of this on the board for my own sake so I don't have to keep flipping back. So they're reporting a number of 0.365. Okay. A county health service planning a new awareness campaign polls a random sample of 750 adults living there. Okay, so, N, the sample size is 750. Cool. In this sample, 228 were found to be obese based on their answers to the health questionnaire. That would be the X value if we were going to go into the calculator to get the sample p hat. I think that's all the information I really need from that. I mean, it was a random sample. Okay, cool. I'm just double checking, making sure, because I don't want to have to flip back a page. That would be ridiculous if I had to keep doing that. Click. There we go. Do these responses provide strong evidence that the 36.5% figure is not accurate for this region? Correct the mistakes you find in the student's attempt to test an appropriate hypothesis. Okay, so let's see what they did, and then I'm going to ask you guys some questions. First, they stated a null and alternate hypothesis. So I'm just going to separate these sections here. There we go. Then I guess this is like assumptions and conditions. Yeah, I'm guessing this is assumptions and conditions right here. And then here is them performing the actual test. Okay. And then there, obviously, is their conclusion at the bottom. All right. I'm going to change my marker to red to make it more ominous. Name something that went wrong with this person. Name one thing that they absolutely, screwed up. Again? Okay. What did you get exactly? 0. Let me get my calculator here. You said 0.07? Let me see what I would have gotten. That's okay. Well, I wouldn't have gotten that standard deviation, but I will agree that their standard deviation is wrong. Their standard deviation is definitely wrong. Question is why? Why is their standard deviation wrong? Ooh. There's one key fatal flaw that they did to calculate their standard deviation. That's a fun noise. 228 divided by 750 is equal to 0.304. What would I label that in my notation? What would I label that as? I'd label it as some kind of letter, symbols. What would I use? Oh, my heart's breaking. It's a proportion, but what would I label it as? Maybe his head's a little cold. It's a p hat. That's your sample proportion. That is a sample statistic. See, the thing is, you were given this piece of information right here. That's their claim. The claim is what you are to assume at the very beginning. And if you are to assume that is the population parameter, then that is how you should be calculating the standard deviation. The calculation should be something like this. 0.365, hold on, 1 minus 0.365, 0.3, I could have done that in my head, goodness. 635, and then the number that I got was similar. Let me just make sure I did this right though. 0.365 times 0.635 divided by 750 in a square root, 0.0 0.0176. 0.0176, or it should have rounded up to 0.018. That's what the standard deviation should have been. Oh, goodness. There you go. But that's what I'm saying. That's the mistake that they made. If you're given the population parameter, you have to use it when calculating that standard deviation. That's one mistake. Name another one. Yeah. Right there. You never use sample statistic notation in your hypotheses. You always use population parameter. You should be using P equals, and P is less than in this case. Well, actually, do these responses provide strong evidence that that number is not accurate for this region? Oh, goodness. They're only testing less than. But the question didn't ask if it was less than. Again, I want to jump back to the previous slide just in case I missed something here. Click, scroll, move. In the sample, 228 were found to be obese, so health questionnaire. Okay. And then back up here, is it lined up? Hold on. Nailed it. There we go. Just noticing this, they're asking, do these responses provide strong evidence that the figure is not accurate? Which means, what should we be using in the alternate hypothesis? We should be using not equal to. Now, again, today is more of a day of like getting to know these hypothesis tests a little bit more. Today, I'm going to be deep diving some more information for you. I'm going to be talking about what not equals to means when you are doing these calculations, performing the test. I'm going to draw some fun pictures. It's going to be great. We'll get into that. All right, so far we found 1, 2, 3 mistakes. The book says 7 mistakes. I found 8 or 9, but I'm nitpicking. What's something else they did wrong? Yeah? They totally botched that. They did 228 is greater or equal to 10. First of all, 228 is the observed successes. You're saying they didn't do the expected successes and failures correctly. Number one, they did observed successes, 228, instead of expected. And they only did successes and not failures. So this is completely meh. So let me just see here. So I don't have to calculate 0.365 times 750 and 0.635 times 750 in order to get this correctly. 0.365. Come on. There we go. And 0.635. Goodness. Okay. Put that there. This would be 273.75, and this would be 476.25. Greater than 10, expected successes, expected failures. I put that in context. I just wanted to write that out there. But yeah, absolutely. That's mistake number 4. There's a huge mistake that they made that is not very obvious. Now, you said not equal to for the alternate hypothesis. What was that originally? Less than. And what'd they do here? Yeah, that's another huge mistake that they made. The alternate hypothesis is going to determine the direction that you actually perform the test in, whether you're performing it on the left end of the normal curve, the right end of the normal curve, or in the case of not equal to, and I'm going to show you this later, both ends of the normal curve. But that's a huge mistake right there. Now, yes, they should have had less than according to their alternative, but then what we would have actually done, because it was not equal to, is I would have kept it less than, and I would have actually doubled that thing right there. But again, those are details that we're going to talk about today. But yeah, they totally botched that as well. That was 5 huge mistakes right there. Oh, goodness gracious. They did state it was a random sample. They didn't talk about the 10% condition. Were you about to say that? Ah, I just ruined it. Yeah?
Do you have to state the independence?
Independence, now here's going to be the key to the whole thing. There are some AP graders that they infer independence based on all of the other things that you did. Independence can be inferred based on the fact that it was a random sample. You had more than 10 successes, more than 10 expected failures. You had a sample size that was less than 10% of the population. There are AP graders that would then be like, we can infer independence from there. You state it, do you not state it? And I prefer to state it. I prefer to state the independence simply because it is consistent, it is thorough, and just in case they're going to require it, you just want to make sure you have it written down. Now, whether that is actually needed for, this particular hypothesis test remains to be seen, but I would state it just in case. It's always better to be thorough in that instance than not. So for the sake of time, because I do have another question that I want to get through, and I do want to get to my notes, let me kind of go through the list right here that they had in the textbook. Number 1, they used P. You're supposed to use P in the hypothesis, not P hat. We got that. Number 2, the question asked not accurate, so the alternative hypothesis should be not equal to. We got that. The correct conditions, less than 10% of the population. We talked about that. And greater than 10 successes, greater than 10 failures. We talked about that. That was mistake number 3. Mistake number 4, they miscalculated their standard deviation. It should have been either 0.018 or 0.0176, which would have rounded up, of course. But they calculated it wrong. Of course, we put those correct numbers in there. Oh, wow. They got the incorrect z-score? Well, okay. Let me specify something about this. The way that they calculated their z-score, the order, the top of the fraction, the bottom of the fraction, that was correct based on their incorrect information. Here's a big secret about AP statistics and the way that they grade things. Here's a huge, huge secret that I need you to be aware of. Let's say it's May. You're taking the AP test. You come across a free response question. Part A, Part B, Part C. You do Part A, and you do it wrong. But Part B asks for information from Part A. Oh no, but Part A is wrong. What an AP grader does, and I swear to you, they do this, they take off the points for Part A, and then they look at the rest of your problem to see if you did it correctly with the wrong number. And if you do it correctly from there on, they will technically count it as correct because they're taking into account the fact that, well, you got it wrong once, we're not going to take off points twice for the same mistake. That is a benefit to you. This z-score is technically incorrect because of the standard deviation. But the way that they calculated it was technically correct. So if this were an AP grader, the AP grader would give them credit for this z-score, but obviously the z-score is now incorrect because we had to fix that standard deviation. It actually should be, I think they wrote it down over here, negative 3.47. It should be negative 3.47. Negative 3.47. So yes, the book is counting it as a mistake. And actually, they combined all of the assumptions and conditions into one mistake as well. Ridiculous. Yep, and then the p-value, I corrected that p-value thing. I never even read their conclusion. Okay, hold on. Their conclusion. There is more than a 99.98% chance that the theta percentage is correct for this region. Oh my gosh, it's terrible. That hurts my heart reading that. Clearly, their 99.98% is wrong, but the p-value, which in their case is 0.9998, which is wrong, it really should be a lot smaller. But the p-value is the determining factor as to whether or not you reject or fail to reject the null hypothesis. It is not about a 99.98% chance of, this percentage being correct. That's not what that is at all. If they were correct, it would be a 99.98% chance of seeing this observed statistic, given that this null hypothesis was correct. Hey. But clearly, this person is in over their heads. What's up? If it weren't COVID, I'd have them throw paper at you. He didn't hear me. It's okay. Oh, where was I? Right. So for this person, if they were being graded on the AP test, they would be graded on that same EPI scale, that every free response question is typically graded on. And if they were being graded on this EPI scale, where's my marker? Did I throw the, oh, there it is. Whew. If they were being graded on this EPI scale, they would lose something for doing p-hat. They would lose something for having the wrong alternate hypothesis. That'd be an I. They never stated the 10% rule. They screwed up the expected failures and successes. That'd be an I. They messed up the standard deviation. I wouldn't take off for this z-score simply because they would have had the wrong standard deviation, but that standard deviation would be a mistake, and then this would be a mistake, not staying consistent with the earlier mistake that they made, so that'd be another I. And this conclusion is absolutely terrible. This is a definitive statement. You're not to make definitive statements. That'd be an I as well. Ah, goodness gracious. On a free response question, you have the opportunity of being graded on a 1, 2, 3, 4 scale. Being that this is all I's, most likely they would give you 1 out of 4. Think about that for a second. You could do all of this work, be completely wrong, get 1 out of 4, and then next comes along the next person who does nothing and gets a 1 out of 4. I don't know. I find that interesting. I want to show you guys something. Actually, in regards to the AP test and grading and whatnot, I want to show you something before I get to that next question, because I had one more question that I wanted to go over. Check this out. Let's see. AP stat score calculator. I may or may not have showed you this before. I don't want that one. I don't want that one. I think that's the one I want. Yep, this is it. Okay. So this is based on 3 years. This is based on the years 2002, 2007, or 2016. Every year, the AP test is on a different level. Some years are harder than other years. Okay. But that's okay because you are being graded against everyone else in the country. Not that you're trying to beat the test, but you are trying to outscore 60% of the country. Or I'm sorry, not 60%, 40% of the country. As long as you outscore 40% of the country, you will be in the top 60%. And typically, the top 60% pass, and the bottom 60% or 40% fail. Now, what this test score calculator does is it says, okay, well, what scores would you have potentially gotten on all of these free response questions? How many of the multiple choice would you have gotten right or wrong? And they calculate your estimated AP score, approximate, based on that particular year. And I wanted to show you something. So let's say that you go in to the AP test and you get, I don't know, let's say you kind of like botch the multiple choice. Let's say you only get 15 right. Let's say you only get 15 right. Then, let's say you get, let's say you get 1 out of 4 here, 1 out of 4 here, 1 out of 4 here. Let's say you get like 2 and maybe 3 out of 4 there or something like that. I'm going to hit calculate in a moment. Chapow! Now that's a failing score right there. But that is pretty darn close. Actually, it's pretty darn close. Let me see here. Let me get another 2 right here. See what it does. There it is. I told you it's pretty darn close. So this is getting 15 out of 40 correct on the multiple choice. Getting a 2 out of 4, a 3 out of 4, and a 2 out of 4. Completely botching the remaining 3 questions. And you still pass. I had a student 2 or 3 years ago, and I can share this story because they are long since graduated. I'm not going to give names. But this student in my AP class, I had the feeling throughout most of the school year, pretty much from like midterms on, I had the feeling that this student was not going to do very well on the AP test. This student kept on missing classes. This student kept on not turning in work. This student was consistently in like the mid 60s to low 70s in terms of the marking period grade. I'm like, everything that I tried, everything that I did, it wasn't getting to where I needed it to be, this student's score. So this student took the AP test and got a 3. And I'm like, what? How in the world did that happen? Turns out this student was pretty good at multiple choice. Pretty good at multiple choice. Because every multiple choice question, you have a 20% chance of guessing it correct. 20%. This student did not leave any of the multiple choice blank. Any of them. Didn't leave any of them blank. And when this student took the multiple choice, they were able to eliminate certain answers so that it wasn't a 20% chance. It was a 25% chance. Or it was a 33% chance. Or even a 50% chance. This student knew how to take multiple choice questions. So now, let's say that you go in and you completely botch the free response. Now, right now, you'd have a 2. But let's say you get half of them right. Holy crap. In 2016, you would have passed. This is a hard damn test. This is a hard damn test. And I say that not to scare you, but to put you into the mindset of passing this test does not mean getting an 80% or better. You are competing against everyone else in the country taking this test on that day. Typically 200,000 students, but it's going to be split up between the 3 sessions. You better believe, by the way, I told you about the 3 testing windows. You better believe there'll be 3 different tests. 3 different tests. Your best chance is when you take the test on a day that most people are taking. Because you know that you're going to have kids who go in, like a different student that I had a few years ago, who are going to go in and literally just sit there and do nothing for the entire 3 hours. I legitimately had a student 2 years ago. The other students told me. The student sat down, said, I'm taking one for the team, guys, don't worry. Completely botched the test because they knew they weren't going to pass. Never even gave themselves a chance. Slept for most of it. Why would you do that? You got to give yourself that chance. I show you this in one sense to show you, yes, it is a hard test. Because think about it. If you only get half of the multiple choice right, completely botched the free response in 2016, you would have gotten a passing score. It's because the test is that hard. And 40% of people scored worse than this. Heck yeah. Anyway, I just wanted to show you that because it was fun. They don't have 2001. 2001 is the year that I took the test. But yeah, hold on one second. AP stat test. Let me see if they have the past percentage passing. Hold on. That's how many are taking it. Here we go. So I know this is a little hard to see, but there's a column right here. Scores of 3 or higher. And you can see every year the number bounces around 60%. Typically a little bit below, sometimes above. This year is way below, but typically it bounces around 60%. You got to score better than 40% of the country. That's all you got to do. And if you score better than 40% of the country, you get a very good chance of passing this test. Huzzah! Anyway, back to the book. Let's see what we got here. Oh, this was the year that I took it right here. I took it in 2001. Yeah. Anyway, where am I? Right there. Okay. I wanted to jump to the question that I said that you didn't actually have to do. It's the question that I kind of put up there as, hey, do this one if you have time, but I'm not going to count it kind of situation. So let me read it, and then we'll talk about what we did with this. The College Board reported that 60.3% of all students who took the 2016 AP Stats exam, it's almost like I can see into the future, earned scores of 3 or higher. One teacher wondered if the performance of her school was better. She believed that year's students to be typical of those who will take AP Stats at that school, and was pleased when 34 out of 54, 34 out of 54 is equal to, let me get this percentage, I like to have a comparison here, 0.63, approximately 0.63. There we go. Which is obviously higher than the College Board number. Achieved scores of 3 or better. How many standard deviations above the national rate did her student score? Does that seem like a lot? Explain. Well, we were going to calculate standard deviations. How many standard deviations above or below? That sounds like a z-score to me. So it's like 0.63 minus 0.603 divided by the square root, because I got to calculate a standard deviation. What number do I put in the square root? What's the first number I put in the square root? I got 2 choices. Huh? Well, that's the sample size. I'm saying what's the first number I put in the square root? Now, the 54 will be put in the square root eventually when I end up dividing by 54, yes. What's the first number I put in? Well, the choices are 63% or 60.3%. What? It's actually not. Oh, you weren't here for that conversation. We went over number 12, where we looked at somebody's hypothesis test and ripped them apart. And you came in at the tail end of that. But I made a huge deal. This is the assumed number. That's the assumed number. That is the assumed population parameter. That is the claim. And innocent until proven guilty, that's what College Board reports. So because College Board is reporting that, we have to assume that until we are, have enough evidence to prove it otherwise or show it otherwise. So we got to put in 0.603. And again, I could probably do this in my head, but again, I'm going to blame it on the vaccine. 0.397. I don't know what that's going to get me, but let's see what happens. 0.63 minus 0.603, divided by the square root 0.603 times 0.397 divided by 54, 0.406. How many standard deviations above the national rate? About 0.4 standard deviations. Does that seem like a lot? No, it doesn't. Why? Well, it's within 1 standard deviation of the mean. And if this were a normal curve, 68% of data points would fall within 1 standard deviation of the mean. So no. Can she claim that her school is better? No, she can't. She could try to claim it. If she tried to perform a one-prop z-test on this, I'm pretty confident, I am pretty darn confident that her p-value would be way too high. And thus, she would not have enough evidence. She would be able to, she would fail to reject that null, the null being the 60.3%. Anyway, I just wanted to show you that just because I kind of put that as an extra one on there, even though I'm not going to count it. There we go. Okay, here's what I need. If you would, ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. Oh, my microphone. What is this? Oh, nice. Do you guys remember Disney original movies? You know, that Disney Plus, their new version of Disney original movies are like Disney Plus originals. Did you know that? No? All right. We just watched the other day Fiona and Ulysses. Has anyone seen it? It's about a girl whose dad writes comic book superheroes, and they're down on their luck, and her parents got separated, and she wants a superhero in real life, and then she ends up finding a squirrel that gains superpowers. It's a great movie. It's live action. Yeah, I know, right? Anyway. I'm just saying, everyone should go home and watch it. I'll lend you my password. And yeah. No, that will not happen. Okay. Today is the 26th, not Derek's birthday. This is hypothesis testing continued. There we go. Now, like I said, I just wanted to recap a couple of things before I build upon our information. First of all, here's the recap. Number one, when you are running a hypothesis test, you need to state your hypotheses. You need to state the null and the alternate hypotheses. This is just a recap. We have this information down, but I'm going to be building upon this in a little bit. You need to check your assumptions and conditions. Absolutely, whatever they may be. Randomness, independence, sample size being large enough, less than 10% of the population, greater than 10 successes and failures. Now, keep in mind that greater than 10 successes and failures only applies if you have proportions. It only applies if you have categorical data. If you don't have categorical data, if you don't have proportions, then you can't check that condition. But we'll get to that. Step 3, of course, you are performing or perform the test. Question is, why am I performing a test? To get a p-value. That is the name of the game. The goal of a hypothesis test is to get a p-value and then make a conclusion based on that p-value. There we go. And copy. And then, of course, you make an appropriate conclusion. Now, I'm going to be getting into the details of what you are required to do when making that appropriate conclusion. We'll get there in a moment, of course, because there are certain statements that you must make. My glasses. There we go. Okay. Couple of bullet points. Couple of bullet points in regards to this. Bring this down here. In conclusion, you will either reject, there we go, reject or fail to reject the null, parentheses, H sub 0. You will either reject or fail to reject the null. You must make that claim in your conclusion. Now, you're not going to be making definitive statements. You're not going to be saying like something is true, absolutely true, like the innocence thing that we talked about. You're not going to be claiming that whatsoever. You are going to have evidence to suggest that something is true, or you're going to have evidence to suggest that something is false. But you will either reject, meaning low p-value, or fail to reject, meaning not enough evidence, comma, p-value too high. I'll repeat that. You will either reject, meaning that you will have too low of a p-value, meaning that your p-value is lower than that threshold that we talked about. I'm going to go into more details in a little bit. Or you will fail to reject, meaning that your p-value is too high. The p-value is actually a bit higher than that threshold that was set at the beginning of the problem. If you're failing to reject, that means you don't have enough evidence. If you are failing to reject, that means that you are proclaiming not guilty, not innocence, but not guilty. Now, I'm going to say a phrase here, but I am not going to write this phrase down. I have never once written this phrase down, but you can if you want. But I'm not going to write it down, and you will understand why in a moment. There is a magical phrase that has been bouncing around the annals of AP statistics classes for the past 20 years. A magical phrase that has helped people to remember what to do with the p-value once you have it. Once you have this p-value, what do I do? Do I reject? Do I fail to reject? What do I do? I have the null hypothesis on trial. Am I rejecting it, or am I failing to reject it? Am I proclaiming guilt, or am I not proclaiming guilt? Oh, this magical phrase, again, that you will remember for the rest of your lives. If the P is low, the hoe must go. You will remember that for the rest of your lives. I swear to you, that has been taught for 20 years. I don't write it down, though. But now there's actually a recording of me saying it. Whatever, I don't care. But in reality, yes, if the p-value is low enough, then you are rejecting the null hypothesis. If the p is low, the home must go. Now, here's one thing you must never do. Here's one thing you must never do. By the way, when I said that, I heard an audible gasp. Like, what? That was fun. Here's a star for you. You will never accept the null. You will never accept the null. Accepting the null is the same thing as proclaiming innocence. A jury never does that. A jury will only proclaim guilt or not guilt. Rejecting or failing to reject, you will never accept the null. That's just the way it goes. You will never accept it. If I dare see anybody write that they're accepting the null hypothesis, or I accept the claim, or anything along those lines, not even using the word accept, but if they say anything to the effect of like, oh, I guess the claim was true. No. That is accepting the null. You will not do that. Okay. But huh? So? Nope. Tell me, when we make confidence intervals, is it possible to have 100% confidence? There you go. Having 100% confidence in something is next to impossible. It's like having a real life scatter plot line up in a straight line. That doesn't happen in real life. You know what I'm saying? Like when you imagine like a country is like firing rockets at each other, for example, some people think like, oh, I'm going to fire a rocket from the United States to England or some junk like that, right? It's not a straight line. There's a curve. There's dimensions to it. There's physics. There's friction. There's so many other aspects that go into it. It's never going to be 100% accurate. Never. Ha ha ha. You ever watch the Olympics? You ever watch archery in the Olympics? Do they hit the bullseye every time? There you go. These are the best archers on the planet, but they still don't get 100%. Anyway. The question is, once you have a p-value, is it significant? Is it significant? Significant or significant? Now I have to Google it. I'm a math teacher. I don't need math. I don't need English. Whatever. Significant. Yeah, spelled it right. In your face, English teachers. You know why English is dumb? It's a made-up language. Just think about it. If you go back 500 years and you talk to somebody speaking English 500 years ago, do you think you'll be able to understand them 100%? Heck no. English evolves over time. You know what stays consistent? Math. Anyway. The threshold to determine if a p-value is, quote, statistically significant is called the alpha level. The threshold to determine if a p-value is statistically significant is called the alpha level. Now, I've told you 5% is, yes, the gold standard, and yes, it is. But that can change. A statistician can set the alpha level to be whatever they want at the beginning of a problem. Now, there's a certain standard. There's a certain standard of guilt, I guess, that you could have for somebody. It's like, what's your standard of guilt for murder? There's a dead body in the room, and he came in late. There's my standard of guilt. That's not very high. That's not a high standard. That's a very low standard. That would be having my threshold of alpha at like 50%. 50%. That's a low standard. If I want to strengthen that standard, and get it all the way down to like 5% or 1%, oh, you came in the room literally with the murder weapon and a note saying I did it. Okay, I'm pretty confident now. A high threshold, a high standard of testing of whether or not something is statistically significant, that means the lower the alpha level. But obviously, you don't want to put the alpha level like, at like 0.000001. That's a bit excessive. As I said, the gold standard is about 5%. So, unless told otherwise, alpha, and yes, that is the symbol they use for alpha. It is the Greek letter alpha, the first letter in the Greek alphabet. You should know your Greek letters because we're going to be using more later. Anyway, is equal to 0.05, also known as the significance level. Is it significance? I'm being serious. English, I love reading. I hate knowing how to spell things and grammar and everything else. But yeah. Oh, goodness gracious. Okay. I'm going to wrap up with this today, with the following couple of statements. A statistician, which we are going to be running these hypothesis tests. We are going to be running what they also call significance tests. That's what they also call them. There's a certain amount of wisdom that goes into it, certain amount of interpretation that you're going to have to do. And we're going to get a lot of practice with that next time. We're really going to solidify this stuff and get this stuff down. But here's the real kicker to the whole thing. As a statistician, you could go out and collect all this data, random sampling, blah, 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 making sure everything's correct, in order to test whether or not this claim is correct or not. Oh, they're claiming, what was the previous one? I don't know, like 36% obesity or something like that. You're like, okay, I'm going to go out and collect data, and here's all my data right there. And I'm going to run the proper hypothesis test. And everything can be very strictly controlled and perfect. Everything's perfect. And I ran my hypothesis test. And I got a p-value of like 0.021 or some junk like that. So because 0.021 is less than my alpha level, I reject the null hypothesis and make my conclusion. And I would look at that study and be like, that's perfect. That's great. Everything that you've done is fantastic. You could still be wrong. You could still be wrong. There is still a chance that you are wrong. Not in what you did. Not in the information that you gathered. Not in what you wrote. Just in general, you could still be wrong. When you have a random sample, there are certain things that you can't control. And you could make 0 mistakes and still technically be wrong. It's like this. It's like, imagine for a moment you're on an airplane and you're going to skydive. And everyone's lining up and everyone's getting their, what are they called? It's a parachute, yes, but what's it like in? Is it really in a backpack? Oh, wow. That's crazy. Okay, cool. So backpack. So you get a backpack on. Now, how many people skydive every year? Like thousands and thousands and thousands and thousands of people skydive every year. You're pretty confident that when you jump out of this plane, you're going to survive. But isn't there the tiniest chance that you're wrong? Heck yeah. You could do everything perfect. These things are called in the statistical realm errors. And we have actually distinctive names for them that I'm going to write down next class. They're called type 1 and type 2 errors. A type 1 error is when you end up concluding that you reject the null hypothesis, but you're actually wrong. And it turns out that the null hypothesis in real life is actually true. Or a type 2 error is when you fail to reject the null hypothesis, and the null is actually false. It's like, again, going back to skydiving. You're given the backpack. You have two choices. You could either reject this backpack, or you can fail to reject this backpack. If you reject this backpack, you're coming to the conclusion that something's wrong with the parachute. I'm rejecting this backpack. If you're right, hey, good. That you realize that something's wrong with the backpack. If you're wrong, well, yeah, you made a mistake. But what's the consequence? You only just don't get the skydive, right? Is that fair? But you could fail to reject. You could also fail to reject this backpack, meaning, all right, give me the backpack. Hey, if you're right, you get to skydive. If you're wrong, you're dead. Yeah, I know.
So to be fair, there's a very small chance that you could fall from third up there. Don't worry about it.
You're talking like that argument's the equivalent of like flipping the coin and having it land on its side. But anyway, we will talk more about that next time. I will have some funny memes as well. If you go on Google and type in like AP stat errors or type errors, and then go to images, I think there's like a funny picture of a pregnant woman. You'll see. I'll show you next time. Anyway, if you haven't left a comment in the chat, please make sure that you do so. I'm about to sign off on this thing. We will pick up with more of this stuff on Tuesday. My goodness. Is Tuesday going to be March? Holy crap. Monday is going to be March. Not to burst any of your bubbles. Go watch Fiona and Ulysses. I'm getting paid. I wish.